We are doing the topic of spot speed studies. I am not asked to complete it. It was a long time ago. Right? Whole 2 days. Huh? Anyways, we looked at why we collect spot speed data. There are some restrictions which you have to follow. It should be in free flow conditions, and some guidelines given in the previous topic as well as this topic, how to collect the data. You have to keep it in mind during your term projects as well. Okay. Then we talked about some calculations with the spot speed data. The main thing was you have to divide it into groups, and then you have to calculate frequencies and cumulative frequencies, and you have a number of observations. We plotted 2 graphs. We calculated 2 types of statistics: central tendency and dispersion. Okay, and then we looked at the equations to calculate sample size, and those equations depend upon how much error you are allowing, tolerance, and how much precision you want to have. The confidence level, 95%, 99.7%. You have to use one of these equations again for your term projects as well. People who came to me for the feedback, I told them about it. Okay, and I also told them, told you in the class as well. Moving on. In the previous topic, I said that speed is directly related to what? Speed studies are directly related to what? No. Speed affects what else? Safety, accidents. Okay. So in many cases, you will find accidents are happening at high speed. So you do something on the side to reduce the speed. It has been done. Nothing new. Okay. So after you do that change on the field, you have to do a before and after study. You have to collect spot speed data before, and you have to collect spot speed data after the change. Okay. What's the idea behind it? We did something on the road to reduce the speed of the drivers. Did we succeed in reducing the speed or not? This is the question. Okay. But the problem is, you collected spot speed data before and you found the mean to be 40 miles, for example. Okay, or 80 kilometers per hour, let's say. The before mean was 80 kilometers per hour, and the after is 78. Is it acceptable? No?
Before was 50.
Before was 80.
Yeah, no.
Okay. 2 kilometers per hour. Difference. You spend 10,000 BD on it. Okay?
How much the required injection?
Huh?
How much the required
This
injection?
is what I am asking.
If
There is a question, right?
Yeah.
This is a question now. You cannot just say, okay, whatever it is. Huh? It was 80, now it is 79, okay, fine. Or 79.5, it's fine. Huh? You have to justify the cost. I did something, I put some effort, I put some money, I did the studies twice. Even in these studies, it will cost you 2000 BD. Okay, I may have used a sensor or something, right? Okay, so how much change is acceptable for me? This is a question, right? Everybody agrees? Huh? This is a question. How much change is acceptable? Yes, there is a change, but how much is acceptable for me? Is 80 to 78 enough? Huh? So we have to ask this question now. Did we produce enough change? This is the question. For that, we do a test. Okay? And that test is known as a Z test. We do a test on the values. We already have the values. We have the values before and after. On those values, we do a test. We call this test as the Z test. Okay? Anybody remembers we used Z for what earlier? Standard normal distribution. Okay? Z is a symbol which is used for standard normal distribution. Okay? So it means the same thing here. So we are comparing the before and after data with standard normal distribution and seeing if we have significant change or not. How to perform the Z test? We will calculate two things, Sy and Z. Okay, we call it ZD because it is a Z for the difference between the two values. You have two values, right? Before now. Okay, so it's not a simple Z, it's ZD, Z of the difference. Okay, so how do we calculate Sy? I need four things. S meaning a standard deviation, and N meaning number of vehicles. Okay, so I need a standard deviation of the before sample and number of vehicles in the before sample. I need a standard deviation of the after sample. I need number of vehicles in the after sample. So this also shows they can be different, right? S1 and S2 can be different, and N1 and N2 can be different. After you calculate Sy, you go to the Z equation. You put Sy here, and you also put X bar. What was X bar? Mean. So again, one means the mean of before sample, and two means the mean of after sample. Clear? Clear? Now, okay, I found the Z value. Now what to do? So Z is a standard normal distribution. Okay? So we will take the value of Z and check it with a Z table. There is a Z table. Okay? This is Z table. Okay? The numbers which you see in the table are cumulative probabilities, cumulative frequencies. Okay? We were calculating cumulative frequencies for our data, right? Spot speed data. Okay? This is cumulative frequencies or cumulative probabilities for Z. You call it frequency or probability, same thing. Okay. So, where is the Z value? Z value is here. In the first column and the top row. The first column and the top row has the Z value. Okay. So, for example, my Z value is 1.69. How much? 1.69. How to read the table? I have three digits, right? 1.69. The first two digits from the first column. So 1.6 from here. Where's 1.6? This one. Okay. What was the third digit? 9. So I will look for the 9 in the top row. So the last column, right? So 1.69. What is the cumulative frequency or probability? 0.95 something. Okay. Okay, I found it. Now what? What I was trying to check. Anybody remembers? What are we trying to check? The difference before and after. Is it acceptable or not? Is it enough or not? Okay. So what? There is a rule now. We'll apply a rule. What is the rule? The value from the table. Which value? But what is it? No, these values are what? Your Z value was how much? 1.69. So these values are what? They are not Z values. They are I told you 2 times what now.
That is it.
See, even she knows you are wrong. These are cumulative probabilities, cumulative frequencies. Okay? So the rule is for what? Cumulative frequency. The rule is not for Z. The rule is for what? Cumulative frequency. Okay? Keep it in your mind. What's the rule? If the cumulative probability or frequency is 0.95 or more, if the cumulative frequency or probability is 0.95 or more, the change is acceptable. Otherwise not acceptable. Got it? Okay?
What?
If the cumulative frequency is higher than 0.9, the change is
0.95 or more.
60.
Accept. Okay. Clear? Now for 1.69, tell me. Z is 1.69. Change is acceptable or not acceptable? Change is acceptable because your cumulative probability was 0.95 something. Clear? Okay. The common mistake is people take the value of Z and apply the rule on Z. Rule is not on Z. You have to come to this table, find out the cumulative probability. The rule is for the probability, not for Z value. Clear? Okay. Any questions? Okay. We have one example. A before and after study is done to evaluate the effectiveness of a new speed limit. So because of a problem, they changed the speed limit on the road, and they did before sample and after sample. The values are given here, and they want us to see if the speed was reduced up to 60 miles per hour or not. Okay. So you have the before mean, after mean, before standard deviation, after standard deviation, and before and after number of samples. Okay, I'll bring the equations from here. I put them here. Okay, give me the value of S, Y, and Z. SY is 0.141. ZD. Huh? 16? 1, 6? Huh? Oh. Either the SY is wrong then. You did the square of S, the standard deviation for SY. Somebody check both values.
It's 1.04.
1.04. Okay, now give me ZD.
$2.19.
2.19. Okay, next step. Who will tell me? Check the Z table. Okay, 2.19. Remember, 2.19. Okay, where is 2.19? Sorry? Yeah, the value which is marked, as you can see. Okay. So 2.1 from here, and then 0.09 from the last column. Okay. So it's 0.9857. What's the rule?
It's 2.21.
It will not change the 2 point. Okay, you know how to see it, right? My value was also 2.19. I don't know. You can see I marked it. Huh? Maybe if you put the SY direct with the decimal places, maybe. Okay. Anyway, it will not change the result. What is the rule? This is 0.98 something. What is the rule?
It's small.
Equal or greater? Equal or greater than 0.95. Then the change is acceptable. Is it acceptable? Is it acceptable here? It's 0.98. Why are you looking like that? I'm saying 0.9.
Yes. It's acceptable.
It is acceptable. Okay, clear? The new speed limit works. This new speed limit works. Okay? Now look at the question. You can still see the last line of the question, right? What is the question saying in the last line? They gave me a value, right? They gave me a value. So only acceptable change is not enough. I must achieve the value. Clear? They are targeting a value. Okay. Okay. Why we are doing this? Let me take the example again for your grades. I love to do this. So for example, somebody took this course before, okay, and they got a D. They got a D, and their overall GPA is less than 2 now. So they repeat the course. Okay. They think we can fool Dr. Unal second time. No problem. Okay. So now they repeat the course. To get their GPA more than 2, they want a B in this course. They want what? B. They have what? D. Okay. They took the course second time. They got a C. Is there a change? Yes, there is a change. From D to C is there a change. But they wanted what? So yeah, there is a change. But the change is not enough. Like, change is not up to my target. Okay, so we found what? There is a change. There is enough change. But is the change reaching my target or not? Now we have to check that. Clear? Clear? Okay. Now they wanted 60, right? They wanted 60. Did they achieve 60? They are looking for 60 where? Before or after? After, right? After. Did they achieve 60 after? No? Why? It's 63, right? They did not achieve 60, they achieved 63. But this 63 is for how many samples? How many samples? 60. Are these the only 60 cards there? Maybe if we took the data of 600 cards, maybe their mean was 60. I don't know. Okay? You see the problem now. I cannot decide based upon 60. I cannot decide based upon a sample of 60 cards or any number of cards. Okay? So what we will do, we'll apply the central limit theorem. Okay? We'll apply the central limit theorem. Central limit theorem says that 95% of the data lies in this range. We discussed about it, right? Normal distribution has a central limit theorem. Okay, Nazariya Haddul Wasat. Right? Somebody told me. Theorem is Nazariya, right? You don't know Arabic? Yesterday some students were complaining. They are asking us to write the summary of our project in Arabic. I said, why you are complaining? I should be complaining. We cannot write the summary in Arabic. Like, I speak in English, they complain to me, we cannot understand you. Now they are asking you to write in Arabic, you are still complaining. Anyways. So, according to this Nazariya, the 95% of the data is in this limit, is in this range. Okay? So what we will do, we will calculate this range for the which data, before or after? After. Okay? So first of all I need what? E. What is E? As our root of n. Okay? So give me E and then the range.
0.77.
Okay. Yes, how much is E?
0.77.
Okay, now I need the range. Huh?
1.5.
What 1.5?
Just 1.6. 1.96.
You do x bar plus minus 1.96 E. X bar is the mean plus 1.96 E. Huh?
64.5.
And point? Okay, the central limit theorem is for two values, right? 95%, 99.7%. You can calculate the 95% range and you can calculate the 99.7% range. We calculated 95%. Okay, calculate 95%. Where else did we use 95% in this question? We already used it. 95% means what? 0.95. It was the rule for the change, right? So we are using 95% because we are using from start to end 95%, 95%. Okay, clear? Confidence interval, the range can be 95% or 99.7%. We are using 95%. Okay, because this is the rule we are using. Our rule is set at 95%. Okay. Now you can see this range gives us 95% data, right? 95% of the data. Okay. So 95% of the data is between what? 64.5 and 62.8. Okay. So the chance to get a value out of this range is only 5%. This range is 95%, right? So out of the range is 5%. Okay. Huh? 61 point what? And the other value? It's okay. It still doesn't change the fact. Okay. Do you see 60 in this range? No. So the chance to get 60 miles per hour is very low. Okay. So we would say we will not take this low chance. We would say we did not achieve 60 miles per hour target. Clear? Okay. So we applied two rules in this question, both of them at 95%. The first rule was when we took the cumulative value, cumulative probability for the z value. Again, if it is 95% or more, we say we have a change, otherwise we don't have it. Clear? Then we applied the 95% rule on the mean. We calculate the range for the mean. If the target value is in the range of 95%, target achieved. If the target value is out of the range of the 95%, target not achieved. Clear? Okay. In this question, the first rule was satisfied, the second rule did not satisfy, right? If the first rule doesn't satisfy, what do we do then? Should we apply the second rule or no? No, why not? Huh? Yeah, the change is not acceptable. So how can you achieve the target? Again, going back to the grade example, you had D earlier. You still have D. So how can you improve the GPA? There is no chance, right? Clear? So if before and after there is no change, or there is not enough change, then how can you achieve the target? The target will be achieved when you have the change, right? Okay? Clear? Any questions? Okay. Another example, same type of data, before and after study. Now they are finding out the effectiveness of rumble strips. What are rumble strips? You see them on the road. You go over them, the car goes like this. Good, fun for kids. Okay, those are rumble strips. You see them before the signal, sometime before the gates and so on. Okay, something on the road which forces the driver to reduce the speed. Okay, clear? So they put these and they are looking to achieve what? 40. Okay. Now we already did the first example. I'll just ask you for the values. Okay. And you will tell me whether we achieved the first rule and the second rule or not. Okay. Start. First of all, the calculation for Z. So give me SY and then ZD. Your name? Okay, and ZD. Huh? 0.67. Anybody else? Same?
Yeah,
Okay, ZD. Okay, let us go to the table. Can you see 4.01? You cannot. It is more than the value in the table, right? The value in the table stop at 3 point something. The value is 4. Okay. So now look at the values of the probabilities. These are cumulative probabilities, right? Maximum cumulative probabilities go up to what? 1, right? After 1, will it increase? It cannot be more than 1, right? So do I need to tell you that it will be 1 and then after that it will stay 1? No. Okay? So that's why the values of probability, the last value of probability is what? 0.999. Okay? Because after that it will be what? 1. So any value after this is 1. Clear? Okay? It will not increase from 1, it will not decrease from 1. So no need to put them in the table. Okay? So for my Z, the cumulative probability is 1. What was the rule? Equal or more than 90.95. Is it more? It is more, right? So the change is acceptable or the change is there. Okay. Now what are we trying to achieve? We are trying to achieve 40, right? So now we need to check if we achieve 40 or not. So we will calculate again the confidence interval. Tell me the values. E equals to what? 0.509. Okay. Then the confidence interval is 39.8 and okay. My required value was 40. Is it in the interval? Yes. So there is 95% chance that I could get a value of 40 as well. And we consider it as a high chance. So we will say going on the high probability that we achieve the required target. Okay. So there is a change, and the change is, there is a high probability the change is up to my target. Clear? Okay. Any questions? Any problem? Okay. Yeah. I talked about theorem, right? Central limit theorem. Central limit theorem applies to what data? Any data? Huh? Central limit theorem applies to central data. To the mean. What type of data? Group data, any group data. Interval, any interval. What is the type of data on which this theorem is applied? I give you one value of speed. Apply central limit theorem. Observe value. I observe one value of speed and I give it to you. Apply central limit theorem to that value. How you make group of values from one value? Okay. And you apply central limit theorem because who told you? Applies to what type of data? Huh? Most frequent value is called as what? The most frequent value is called as what? MVP value. I never heard. And since I never heard of it, I wouldn't have mentioned it in the class. Right? So find out. Find out what type of data central limit theorem is applied to. Okay. Anyways, there is another test to check the type of data. Okay, and since obviously now we have to do this check, so I hate to tell you, but I have to tell you, this check checks if the data is normal or not. We apply central limit theorem to normal data which has a bell-shaped curve, the most probable value in the middle. Okay, it looks like your most probable value, most repeated value will not be in the middle. For you guys it will be somewhere near F or D. Okay. Anyways, so we have to perform a check to see if I can apply central limit theorem to my data or not, and that check is called as a chi-square test. Some people call it chi-square test, but I don't call it that because I love chi, so I cannot call it that. Okay, so chi-square test. In chi-square test, we do n minus f upon f. What is n? You already know it, right? What is n? Number of vehicles in each group. Okay, number of vehicles in each group. What is f? We have to calculate f. Okay, we have to calculate f. Okay, yeah, it is called as the theoretical frequency. It is the theoretical frequency. Right now we don't have it. Okay, we will see how to calculate. Okay, so you will calculate chi square, and then we will see if the data is normal or not, if we can apply the central limit theorem to the data or not. Okay, for performing the check we have to do some calculations to calculate f basically. Now remember, this is the same data which we have seen earlier. For this data we have calculated the mean and the standard deviation, everything. Okay, this is from the last example. Okay, but I will tell you what we do with the data. First of all, arrange the data starting from infinity and ending at minus infinity. The first group starts at infinity and the last group ends at minus infinity. Okay, so the highest value is infinity, the lowest value is minus infinity. Then after infinity onwards till the last value, you put your groups. Okay, so my first group was 66 to 64. So I made it infinity. So instead of 66 to 64, now it is infinity to 64. And the rest of the groups are same. 64, 62, 62, 60 and so on. Clear? Okay? And again the last group, it was how much? 34 to, what to 34? 32 to 34. It was 32 to 34. Okay, but I made the last value as minus infinity. So I remove 32 and put minus infinity. Got it? Okay. Then you put the number of values in each group as you have observed in the field. This is observation. Okay. The actual group was 66 to 64.
Yeah, but now this.
So there is nobody above 66, right? The last value was 66, and there is nobody above it. So if I remove 66, what does it matter? From 66 upwards, there is nobody. So it's already 0. Okay, so 2 is between 66 and 64, and all above is 0. Okay, so 0 plus 2, how much? 2.
But maybe there is more.
So that means you made the group wrong. The last group is not 64 to 66. It should be from 66 to something else. Got it? Okay. Clear? Clear or not? Okay. The first group should have the maximum speed. The last group should have the minimum speed. If your grouping is correct, then it will work. If your grouping is not correct, then there is a problem. Okay. So these are the values from the field. Okay. Clear or not? Okay. Next, I will take this column, the first column, and convert every value to z. I showed you this equation in the last lecture as well. Okay. X is the value from the first column. Mu is the mean of this data. I told you this is the data from the previous example. So we already have calculated the mean. Its mean was 48.2. Okay. And sigma in the denominator is the standard deviation of the data. Again, we already calculated the standard deviation. Okay. For this data it was 6.14. Okay. If somebody gives you the data, you know how to calculate mean and standard deviation. Okay, I know you don't remember, but we did. Just trust me. Okay. So, for example, I take this value, 64. I do what now? 64 minus mean. What is mean? 48.2. Upon sigma. What is sigma? 6.1. So you get how much? 2.5. Clear? Okay. And you will do this with each value. Okay, so you put 62, then 60, and T and so on. Clear? Okay, the mean and standard deviation will not change, but the values will keep on changing. You will have a different Z value. Okay, look at the first value in the Z column. What is the first value? What is the first value in the Z column? Z column. Z column. Can you see the Z column? Infinity, right? The first value in the Z column is infinity. Why? Because this is infinity. And you put infinity in the equation, what will happen? Infinity minus anything, above plus anything, above anything, below anything, it is infinite. Okay, so that's why infinite. Clear? Okay. Now look at the next column. Next column is coming from the Z table. You pick each value from this column and go to the Z table. Pick each value from the Z column and go to the Z table. Okay. Again, I'll start from the second value. What is the second value? 2.57, right? So I go to the Z table. Where is 2.5? Here. 2.57? Here. Okay. So 0.9949 is this value. Clear? Okay. Again, the first value was what? Infinity, right? The first value was infinity. What is the probability of infinity here? 1. Why? Because it is more than the table. Okay, so it's always 1. One more thing here. You see some Z values are negative. Now what do I do with the negative value? I cannot say it's more than the table, right? It's less. It's negative.
So it's not more than 95 or 0.9.
It's not more. There's a table for negative, yes. There's a table for negative values as well. You read it in the same manner. Okay? But let's say there is someone like me who just gave you this table. Then what do we do? 1 minus. 1 minus what? The positive. So for example, the first value is what? The first negative value is how much? Minus minus 0.03. Okay, forget about minus. Can you look at the probability for 0.03? 0.0 is here and 0.03 is this one. Okay, so it's 0.5120, but it is for 0.03. I want for minus 0.03, so I will do 1 minus this one. Okay, so if I want the probability of minus 0.03, I'll do 1 minus probability of 0.03. Clear? Okay, whenever you have a negative Z value and you don't have the negative Z table, just forget about the minus sign, find out the probability. Once you find the probability, do 1 minus that. Okay, so in this case I will do 1 minus this value, 0.5120. Clear? 1 minus the probability, remember, not 1 minus Z. Okay, everything is applied on the table. Clear? So if you do 1 minus 0.51, it will give you this value. Where is it? Okay, and what is this? So I took the probability of 0.36. Whatever that value was, I did 1 minus that value. So I got 0.35 something. Clear? Got it?
Which one minus it? You said the 1.
1 minus the probability.
You said the Z value.
No, I'm wrong. Sorry. Okay. Happy?
Yes.
Okay. Next thing, what do we do? These are cumulative probabilities. The values which you took from the table are cumulative. Are what? Cumulative. Now what I will do? I will take the probability for each group. Now I don't want cumulative, I want for each group. Cumulative means what? Sum, right? So now for each group I will subtract. Okay, for each group I will subtract. Okay, so I'll subtract the first two values I'll get for the first group. Okay, so 1 minus 0.9 and 49, first group. Next two values, next group. Next two values, next group. Okay, clear? So I want for this group, right? Okay, what is the first probability? 1. What is the second probability? 0.9 and 49. This will give me the for the first group. Okay, for the second group, then you do 0.9949 minus the one after this. Okay, which is, so it will give you for the second group. Okay, clear? Huh? Okay, now what do you do with these values? You have probability or percentage for each group. Now you multiply this percentage with the total number of values, summation of n. Okay, the percentage of each group will be multiplied by summation of n. Okay, so if you do the summation of this column, we already did it, like I said, you will get 368. Summation of n is 368. So each of these values multiply by 368. Okay,
Which value?
these values, the one which you just calculated. Okay, so for example, how did I get this one? Look here, everybody, look here. How did I get this 40? I took this value, multiply by total number, 368. Got it? How did I get this value? 4.74. This value multiply by total number. All of them multiply by the same number. Clear? Clear? Okay. Now let us stop here because there are a couple of steps more. Now these values is what we call as f. Remember, the theoretical frequency. We are doing it for this test. Remember, I want to perform this test. I already had n. I just calculated right now. The last step I calculated is f. Okay. So I have both these values now. I can calculate chi-square. Clear? Okay. We will do it. No problem. The problem is not finished. Okay. What we have done, we already knew n, and now I calculated f. Okay. Okay. I would say that you take these columns, the first 3 columns, and calculate everything up to f yourself. Why? Because we didn't do it in the class, first of all, so you have to do some practice. Okay, I cannot do these 20 values in the class. Second, if you don't know this, we cannot move forward. So when you will do practice, hopefully you will remember when you come on Sunday. Okay? Sunday will be Ramadan or after that? Monday. Okay. So still, hopefully, your brain will be on Sunday. Okay? Thank you.